So, continuing our discussion of acids and bases, I want to define now pH and see what that does for us and how we can use that to define acids and to quantify concentrations of acids and bases. So, something you should know about water is that to a very, very small degree, it dissociates on its own. It's called autoionization of water. Water auto-ionizes itself, meaning that water, liquid here, will by itself become H plus and OH minus, meaning it's sort of like an acid and a base together, isn't it? It does both. So how slightly? At 25 degrees Celsius, we have this autoionization constant called Kw, K subscript W. It is given as the concentration of H times the concentration of OH, and it is this small amount, meaning that if they were equal, you would get 0.00000 whatever 1 moles of each one of these per 1 liter of water. That's tiny. That's why it's you don't really notice that. If I get a cup of water, you're not gonna start drinking H pluses and OH minuses. You're not gonna start seeing them. It's very small, but it's enough to help us dictate what the pH of a solution is. And let's see exactly what that is. So in chemistry, this little subscript P, what that means is negative log base 10. So if I have P of chicken, it would be negative log base 10 of chicken. If I have pH, it's negative log 10 of H plus. So this is, you take the concentration of H plus and you throw that inside of a log, you negate that, you get the pH. Okay, it's the negative log of the concentration in molarity of H plus. Note then that as I increase H plus, I will decrease my pH, which means that a strong acid is going to have a lower pH than a weak acid. Okay, and mathematically we say that anything that has a pH of less than 7 is acidic. Anything that has a pH of greater than 7 is basic, and if it's exactly equal to 7, it is neutral. Okay, so if it's less than 7, it's acidic. If it's like 1, it's terribly acidic. If it's 6, it's a little acidic. If you're comparing two things that, and you could figure out which one would be more acidic. You can have something that has a 0 pH. Okay. Let's try to see how one would calculate the pH of a solution. So calculate the pH of a solution of H plus. If my concentration is this, 1 times 10 to the minus 7th, well, I'm going to throw that into this definition. pH is negative log of H plus. I'm going to put that in here. You put that in here, you get 7. If you put that in here, you get 8. If you put that in here, you get 9. If you put that into the definition, you get 2.43. So the higher the concentration, the lower the pH. Okay. How do you calculate pH? Well, if I know the concentration of hydroxide, can I calculate the pH? I will remind you that OH times H is 1 times 10 to the minus 14. We showed that as the autoionization constant before right here. So that's always going to be true. And here, I can, based on that, get the H. So if I take this and I divide both sides by the OH, I will get what H is. And so H is going to be exactly this. H will be 1. So if I know the concentration of OH minus, I can get the concentration of H plus. Now I'll put that into the negative log definition and I will get that my pH is 0. So the pH of this solution is 0. Okay. Another example would be if the concentration of OH minus is 1 times 10 to the minus 13th, I'll do the exact same thing. 1 to the minus 14th divided by 1 to the minus 13th. I'll get 0.1. I'll throw that into the negative log and I'll get that my pH is 1. Okay. And let's calculate now OH minus if I have the pH. Okay, now I will summarize this in a second. It's very simple, and once you see all these examples, we know that pH is negative log of H. So if I solve for H, H is 10 raised to the negative pH, meaning what? If I know, I can get the H plus from the pH directly. If I have the pH as 3, I will put the pH here, and I'll get that my concentration of H plus is 0.001. Okay? And I know that H times OH is 1 times 10 to the minus 14th, and therefore I can get the concentration of OH minus. And in summary, if I give you the pH and you want to know the concentration of H, do that. If I give you the pH and you want to know the concentration of OH, do that. If I give you the concentration of H and I want you to find the pH, do that. If I give you the concentration of OH and I want you to find the pH, do that. Those are the 4 things I just did. Those are the only 4 things I could do. So if you figure this out, you got this. There's no variation on pH. This is it. Okay. There's one extra thing though. It's called a POH. Just so you know, this is not as commonly used, but I just want you to be aware of it. I can define the POH as a complement to the pH, and instead of having negative log of H, it's negative log of OH. Like I told you, P dog would be negative log of dog. POH is negative log of OH. And so in this system, I have the opposite. If the POH is less than 7, it's a base instead of an acid. If the POH is greater than 7, it's an acid, not a base. So just be aware of it, that it does exist, but mostly we will use pH, and you will see mostly these questions because pH is something that people actually use, POH not so much. Okay, let's talk a little bit about electrolytes. That's an interesting thing to talk about too. Electrolytes are compounds that when they dissociate in water, they can complete an electric circuit. Okay,